Let's now look at our general procedure for adding rationals. If we want to add two rational expressions, p of x over d of x plus q of x over e of x, then we need to get common denominators, which is just like what we did for fractions. Now, to keep the degrees of the polynomials as low as possible, we factor the denominators of d of x and e of x to look for common factors. For example, d of x may be the quadratic a times x minus k1 times x minus k2, while e is the quadratic b times x minus k1 times x minus k3. However, we could have higher degree polynomials that we do this the same way. Now, for any missing factor from one of the denominators, we need to multiply the top and bottom of that rational by the missing factor. For example, we have a times x minus k2 in our first rational, but not in our second one. While in our second rational, we have b times x minus k3 that aren't factors in our first rational. So we can multiply the first rational by b times x minus k3 over b times x minus k3, which is just 1, and our second rational by a times x minus k2 over a times x minus k2, which again is just 1. Notice that since x minus k1 shows up in both of our rationals, we don't need to multiply our denominators by that factor. It's also worth pointing out that the factors may be constants, like a and b, or polynomials, like x minus k2 and x minus k3. Now, with the common denominator of a times b times x minus k1 times x minus k2 times x minus k3, we can add the two fractions by simply adding across the top. So from our first fraction, we get b times x minus k3 times p of x, and from our second fraction, we get a times x minus k2 times q of x, all over that common denominator, ab times x minus k1 times x minus k2 times x minus k3. Now, we will likely need to distribute in the numerator to simplify. But factored form is often useful, and since the denominator is already in factored form, we typically leave it as is.